The information in this video is based on the most current information available at the time of production. While affordable safety training works hard to make sure these materials are current, the employer has sole responsibility for compliance with all laws, regulations, and standards. This video is sold with the understanding that AST is not providing professional or legal advice. Employers should have a reliable source for current regulatory information and best practices.
Was killed and 3 others injured after a scaffolding accident.
Oh no!
This explosion rocking Midtown Atlanta Friday night after the scaffolding
Their
holding...
son's death after a catastrophic workplace accident. A gigantic scaffold at a construction site collapsed at Macquarie Park near Rye.
Hello, my name is Jeremy and welcome to Supported Scaffold Safety Training. This is one of my favorite subjects to teach as it often brings me the most heartburn. I can't tell you how many times I've walked down the street going, trying to avoid looking because somebody's doing something treacherous on scaffolding. But here, today, we will avoid that by learning how to work safely on supported scaffolds. This subject is covered by OSHA Regulation 29 CFR 1926, Subpart L, Scaffolds. In this course, we will address common hazards in the work area, such as electrical hazards, falling object hazards, falling hazards, and other hazards. The correct procedures for managing those hazards. Understanding the maximum intended load of a scaffold. Load carrying capabilities of a scaffold, and additional tips and tricks for scaffold use. All right, let's get started.
Common types of supported scaffolds.
Fabricated frame. Ladder jack. Mast climbers. Mobile. Wood pole. Pump jack. Tube and coupler.
Scaffolding capacities vary by type and construction. OSHA requires that supported scaffolding and its components have the capacity to carry the weight of it itself and at least 4 times the weight of the maximum intended load. OSHA defines the maximum intended load as the total load of all persons, equipment, tools, materials, transmitted loads, and other loads reasonably anticipated to be applied to the scaffold or scaffold components at any one time. So it's the total weight of everything: people, equipment, tools, whatever's on the platform. These are important concepts. They will keep your scaffold from collapsing if they are applied correctly. The maximum intended load for the work must be determined. It should be noted that the maximum intended load isn't likely to occur during normal activities. It's probably going to occur during some infrequent event like the installation or removal of equipment. So plan ahead and be sure to consider all possible scenarios when determining a maximum intended load. Once you determine the maximum intended load, you need to select a scaffolding system that can carry at least its weight and 4 times the maximum intended load. Now, if you use a purchased scaffolding system, most manufacturers will just save you the math. The manual or procedure for that equipment will list a maximum intended load that complies with that rule. For instance, pump jack scaffolds typically only allow 2 people on the platform and a maximum of 500 pounds applied directly in the middle between the 2 poles. If you follow that rule, it will keep you beneath the 4-to-1 requirement. It becomes more of an issue when you are constructing your own scaffold system. You will need a qualified person or a registered professional engineer to determine the maximum scaffolding load. So remember, scaffolds must be able to carry its weight in 4 times the maximum intended load.
A competent person is one who is capable of identifying existing and predictable hazards in the surroundings or working conditions, which are unsanitary, hazardous to employees, and who has authorization to take prompt corrective measures to eliminate them. The responsibilities of a competent person include selection, training, and supervision of employees who erect, dismantle, move, or alter scaffolds. To inspect scaffolding and components before each work shift, and other times as required. To determine the safety and effectiveness of scaffolds when intermixing of components as required. A qualified person is one who, by possession of a recognized degree, certificate, or professional standing, or who by extensive knowledge, training, and experience, has successfully demonstrated his or her ability to solve, or resolve, problems related to the subject matter, the work, or the project. The responsibilities of a qualified person include to design and load scaffolds safely, to train employees on how to recognize associated hazards, and the procedures to control and minimize these hazards. A registered professional engineer is required to design scaffolds that are to be moved with employees on them. To design fabricated, or tube and coupler scaffolds over 125 feet. To design pole scaffolds over 60 feet.
Electrocution is a serious hazard on construction sites, especially for scaffolding work. When scaffolding contacts a source of electricity, the results can be catastrophic. Watch what happens to these 3 workers. They are moving a mobile scaffold and it contacts a source of electricity. Warning, this video isn't graphic, but it is disturbing. You can see one of the workers in the video look up to see what they contacted. So how do we prevent terrible accidents like this one? First, we need to discuss when they are most likely to happen. That would be the scaffolding is being erected, the scaffold is being moved, or a power line is moved by some other type of work that causes it to contact the scaffold. OSHA has specific rules about the proximity of scaffolding to power lines. Insulated lines under 300 volts require at least 3 feet of clearance. Over 300 volts, 10 feet of clearance is required. Additional clearance distances are required for 50 kilovolts and above. Uninsulated lines require 10 feet of clearance with additional distances above 50 kilovolts. It is the responsibility of a competent person to identify potential electrocution hazards and take steps to prevent them. OSHA does allow for reduced clearances provided that the utility company has been contacted and additional steps are taken. This may include de-energizing the line, moving the line, or insulating the line. Now in this section we're talking about clearance distances for scaffolding equipment, but don't forget about the requirements for clearance distances for employees. Unless they are qualified electrical workers, they must stay at least 10 feet away from energized lines. So let's say if your scaffolding has 13 feet of clearance, but an employee standing on the scaffolding is only going to have 7 feet of clearance from the energized line, they are violating the clearance distance rules. All employees working on a scaffold should know the location of any power lines in their vicinity. Keep a close eye out for any other work in the area. Certain types of evolutions, such as the use of cranes or aerial lifts, can accidentally displace a power line and put you at risk. Falling objects are dangerous and they are the cause of many injuries on construction sites. One time, the head of a tensioner fell from a wind turbine which was about 200 feet in the air, down to the ground, missing me by about 2 feet. It was terrifying. The first thing you need to do to protect yourself from falling objects is to wear a hard hat. OSHA requires that all workers on scaffolds wear hard hats. Additional steps to protect from falling object hazards are also required. You have 3 basic options. You can block, you can catch, or you can isolate. Blocking involves using things like toe boards, screens, and guardrails to provide a physical barrier. This barrier will prevent objects from falling over the edge. You can use debris nets, catch platforms, or canopy structures to catch falling objects. These must be strong enough to catch any or all objects that may fall from a scaffold. If blocking or catching is not an option or is insufficient, the area beneath a scaffold platform must be completely isolated. You must post danger signs and prevent employees from entering this hazardous area. It may take a mix of these 3 options to provide adequate protection from falling objects. A competent person will assess the falling object hazard and design an appropriate solution. Remember, a competent person is somebody who has the ability to recognize hazards and the authority to correct them. Falls are the leading cause of injury on the job site. I spent much of my youth teaching people how to climb and work safely on wind turbines, so the subject of fall protection is near and dear to my heart. 29 CFR 1926 Subpart L, Scaffolds, requires any employees who are 10 feet or greater above a lower level to be protected from falling. The scaffold standard is what OSHA refers to as a vertical standard. Vertical standards take precedence over horizontal standards. Normally, 1926 Subpart M, fall protection, will require fall protection at 6 feet or greater above a lower level. But the horizontal standard of scaffolding takes precedence in this case, and it sets the standard at 10 feet. However, fall protection is still required at 6 feet or greater above or lower level when accessing scaffolding via stairways, ramps, or walkways. There are 2 authorized methods for providing fall protection on scaffolds. The first method is guardrails. Guardrails are the preferred method for providing fall protection on scaffolds. They provide a physical barrier that eliminates the possibility of falling. Most scaffold systems either come with guardrails or have the option for installing guardrails. A competent person should review your options and see if guardrails can be used on your scaffold. If guardrails are not an option, a personal fall arrest system must be used. Personal fall arrest systems are complex and require specialized on-site training. This training must be provided by a qualified person in fall protection. Let's cover some basic concepts for fall arrest as it applies to scaffolds. Personal fall arrest systems have 4 components: a harness, connectors, anchor points, and a rescue plan. It is the requirement for a rescue plan that is most frequently overlooked. When using a fall arrest system, the employer must provide prompt rescue of employees or ensure that employees are able to rescue themselves. There are 3 options for anchoring a fall arrest system. You can connect to a vertical lifeline, a horizontal lifeline, or a scaffold structural member. Vertical lifelines must be connected to a safe anchorage point that is independent of the scaffold. This includes building structural members, but does not include things like electrical conduits or piping. The anchor point must be able to hold 5,000 pounds per person attached. So if you can't hang a pickup truck from it, it's probably not a safe anchor point. Horizontal lifelines must be connected to at least 2 or more structural members of the scaffold. The scaffold must be strong enough to use a horizontal lifeline for fall arrest anchorage. If it is allowed by scaffold design, you can anchor directly to the scaffold itself. There are advantages and disadvantages to each anchor point option. Vertical lifelines are commonly used because it's pretty easy to find a strong anchor point on the adjacent building. A lot of scaffolds aren't rated to arrest a fall, so a strong anchor point on the adjacent building gives you that strength you need. The downside to this is that you are anchoring directly above you. When, for work, you move out from directly underneath that anchor point, you open yourself up to the risk of swing fall. This happens when you fall and you are not directly beneath your anchor point. Your connection point on a horizontal lifeline moves with you, so you don't have that same risk of swing fall. Connecting directly to the scaffold can also be easy, but it tends to limit your movement. The problem I most often see when people are using fall arrest on scaffolds is not that they're not using the equipment, it's that they're not high enough off the ground for the equipment to actually work. This concept is called required clearance, and it frequently trips people up. Required clearance is the working height that is required for an employee not to hit the ground in the event of a fall. And it is much, much higher than you might think. A 6-foot worker using a 6-foot lanyard anchored at shoulder height will require about 17.5 feet of clearance beneath the anchor point in order to not hit the ground in the event of a fall. The lanyard is 6 feet long. A harness gather of 1 foot occurs when the employee falls and the harness pulls up on their body. The deceleration equipment adds an additional 3.5 feet. You have the height of the worker from the shoulder down, which is about 5 feet in this case. And there is a 2-foot safety factor. Add that all together and you have a required clearance of 17.5 feet. So if they are less than 17.5 feet off the ground and they fall, they're going to hit the ground. There are easy ways to reduce the amount of required clearance. The best thing to do is just simply use a shorter lanyard. Anchor to a point as high above you as you can. Look at this guy. He's got his rope grab all the way down by his feet. That's going to add an additional 5 feet of required clearance. And when he falls, he's going to exceed the maximum allowed free fall distance of 6 feet. So keep that anchor point as high as you can. I often see issues with the setup and use of vertical lifelines. Take a look at this. The anchor is connected to the roof peak. If someone falls, the lifeline will slide all the way down the roof to the bottom. There is no protection provided for the lifeline, so it can easily be damaged by friction on the leading edge of the roof. And the lifeline itself runs through the scaffold bracing. So if a worker falls, that lifeline is going to rip apart the scaffold bracing and probably take the entire scaffold down with it. These two are connected with vertical lifelines positioned at either end of the scaffold. As you can see, he is working in the middle. This is a swing fall hazard. If he falls, he's going to swing out and possibly contact that concrete wall down there. A horizontal lifeline, or maybe just guardrails, would probably work better in this situation. In summary, employees who are working 10 feet or greater above a lower level on scaffolds are required to have fall protection. Guardrails are the preferred method. If guardrails cannot be used, then a fall arrest system must be employed. Personal fall arrest systems must be connected to a vertical lifeline, a horizontal lifeline, or a scaffold structural member.
Scaffolds shall be inspected for visible defects by a competent person before each work shift, and after any occurrence which could affect a scaffold's structural integrity. Scaffold inspection requirements will vary, depending on the type of supported scaffold in use. Here are some common inspection items to look for. Scaffolds should be plumb, level, and square. The components and platforms are in good condition. Brackets, tubes, and clamps are properly placed and secure. Casters are locked before work begins. Guardrails are in place on all open sides where a worker can fall 10 feet or more, or fall arrest is provided. Top rails are between 38 and 45 inches high. Falling object protection is installed and in good condition. Platforms are free of debris and slippery surfaces. Spaces between planks do not exceed 1 inch. Platforms do not deflect more than 2 inches every 10 feet. Scaffolds are clear of nearby electrical hazards. Workers have safe access to the scaffold. Deficiencies must be repaired or replaced immediately, or the scaffold must be removed from service.
Alright, in this section we're going to talk about working safely on supported scaffolds. We'll talk about what to do and what not to do. The first thing is access. Workers must be provided with safe access to scaffolds and scaffold platforms. When the platform is more than 2 feet above an access point, stairs, ramps, ladders, or some other form of access device must be provided. If the worker is 6 feet or greater above a lower level while using ramps or stairways to access a scaffold, guardrails must be provided. Ladders may be used for supported scaffold access if they are specifically designed to be used for that purpose, and the scaffold that is being accessed is also designed to be used with ladders. Never climb on the cross braces to access a scaffold. Do not allow debris to collect on the scaffold platform. They can cause tripping hazards and falling object hazards. Do not use boxes or other objects to increase the working height. Ladders may not be used on a scaffold platform unless it is part of a large area scaffold system. Employees may not work on scaffold platforms that are covered in snow, ice, or other slippery material, except when they are doing so to remove it. Tag lines must be used when items are being hoisted onto or near a scaffold. Stay at least 10 feet away from all power lines. Do not work on scaffolds during high winds unless a competent person says it's okay, provides extra protection such as fall arrest or wind screens. Do not move scaffolds horizontally while employees are on them unless they are specifically designed for that purpose and special precautions are taken. Do not use platforms as elevators or equipment jacks. Do not throw objects down from the platform. Put tools and equipment away when not in use. Immediately notify a supervisor if you have any safety concerns.
Supported scaffolds are platforms with rigid supports, such as poles or beams. They must be able to hold its weight, and 4 times the maximum intended load. Scaffold design and loading must be performed by a qualified person. Scaffolds must be at least 10 feet from power lines. Scaffold systems must include falling object protection. Scaffold fall protection is required and working 10 feet or greater above a lower level. Scaffolds must be inspected by a competent person before each work shift. Access means must be provided for platforms 2 feet or higher. Tag lines must be used when hoisting near scaffolds. Put tools and equipment away when not in use. Notify a supervisor of any safety concerns. Avoid working in dangerous weather conditions.